Hello! You're in for a treat.
Tuesdays and Wednesdays and Thursdays.
2 West.
6 to 7:30 p.m. Eastern Time.
We got new hours because we're nerdish.
And we're in our 20s despite our looks, so we gotta do things in the evening time over the summer.
Correct, but not too late because, as Levi said, we're in our mid-20s.
Not our early 20s.
And not our late 20s, the mid-20s.
So, yes, we're the Goldilocks of 20s.
That's right, I shouldn't have laughed. I gotta keep it cool, because this is our intro rap, where we keep things cool.
We're very cool, so cool we might want a dance break.
Hey, thanks for watching our dance break.
Now, back to the really serious stuff.
Like Brady
And Levi.
and Brady too. We're the 3 members of the Nerdish crew.
That was perfect. We didn't plan that.
Not at all. We don't plan anything. If you couldn't tell by this rap. That was the one thing we rhymed.
That was the one thing.
Which makes it a rap.
Yes, all raps have one rhyme.
We'll see you on 2 West.
Yes. 2 West.
6, 7:30 p.m.
Eastern Standard Time.
Keep watching, because it'll turn into us, but probably not wearing the wigs.
Yes, and we'll be much more responsive to whatever you have to say.
You could ask us questions right now. We will not answer them.
Also, we take no responsibility for anything we've done in this pre-recorded session.
Yes. Any lost items, Nerdish is not responsible.
Right, we don't have anything to do with it. We're very different people in the present than we are from when we're recording this video. You might say we are the pupae of Nerdish right now, and in the future we will be the moths.
The
Because moths are the
disgusting
most-
gray moths.
Yes, those gray moths that you hear, they're
Yeah.
like the bats of the flying community.
The wings are leathery. They're leathery wings.
Very leathery.
They're basically butterflies, but we hate them.
Yes.
They're the rodents of butterflies.
This is true.
Right?
Just like the ACT is the rodent of the SAT.
I don't agree with that. I don't agree with that at all.
Hello, you sweet, sweet nerds, you. How are you? Nerdish is now streaming live, according to my chat here, so that's good. We don't have any questions in the Discord right now or in chat, so I'm just gonna stall. Oh, Turtles, what's up? Do you have questions, Turtles? Do you have questions? It's a bountiful harvest of answers. Hello, Minkyo. Hi. Bird, do you want to say hi or no?
Yes.
Okay.
Oh,
Yeah, I'll bring some up. Yes, you will.
Look who's here.
It's Turtles and Minkyo.
I want to see them. Why are you doing this to me?
Doing what?
Who's here? Turtles and Minkyo?
Yes.
Very good. Very good.
Ask your question.
Levi will be handling the beginning of the stream. I will be handling the latter half of the stream. Actually, the latter 2/3.
Oh, you burped me, Bird. I burped.
I don't want you to have to spit up.
Thanks. SAT in 4 days. Yup. Are you excited? We can ask last minute. Oh, right. Hey, Brady.
Yep.
We didn't discuss doing are we going to do a cram session on Friday?
Maybe on Thursday.
We're not.
Yeah.
Great. Just checking.
Yeah, okay.
Alright. I've been doing some in-depth analysis of Erica Meltzer's book for the past 2 days. You're analyzing the book itself, or like you're just practicing with it? I've heard good things. I've seen good things. Oh, wow. It's clutch as F. That's very good. Hey, Prod. How are you? Okay. You guys got to ask me some questions so I can tell you the answers. Or I can show you... I'll tell you the answers, but I will show you how to do the things. Just going over the ideas. Her ideas. Yes, very good. Da, da, da. Da, 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 da. Don't know what's going on there. All right, there are no questions for stream at the moment. You guys should ask some so I can answer them. That is what this is, of course. Who's taking the SAT this Saturday, aside from Minkyo? Are you guys familiar with all the curves? I just said familiar with all the curves. Are you asking us guys or your chat people? You're taking the 24th. Hey, chemist. I'm looking through my stuff, but I have some general questions. Yeah, let's do general questions. What are your tips for the morning of? What are your tips for the night before? Very good. So, you guys, not chat. Great. What was your question? What curves? Like trig functions and things, and like how they shift and things like that. We can talk about that. Tips for the morning of and the night before. Okay, so you want to do normal stuff. Now, if you do, a bunch of drugs on a normal basis, maybe don't do that. But get a normal amount of sleep. I think 2 nights before and 3 nights before are every bit as important as the night before. You want to keep your schedule consistent so that your body's not dealing with any new stuff. You're going to have to adapt during the test because things are probably going to be a little bit wonky and you're going to be stressed out. So try to keep everything else consistent. If you have junk food every night before you go to sleep, just have junk food again. Don't have a lot, maybe have a little bit less, but don't change up too much. I've heard a lot of things from August SAT curves because I heard it's terrible and I can't seem to find anything about past August tests online. Yeah, so August is not one of the QAS tests, so there's going to be less about it that you'll know. I put question in Discord. Thank you for putting the question in the Discord. Yeah, so we'll keep talking about that night before and then morning of. Where did you put the question? Whoa. Proud, where in the Discord did you put the question? You put it in SAT or ACT, or did you put it in hours? And is chemist, is this a question you want us to do that you wrote here? Or are you just telling us? So, night before, normal stuff. Don't do anything crazy. Obviously, you want to sleep. Do your normal thing. There it is. Who's Pale Moon? Prod, are you Pale Moon? Or is Pale Moon somebody else? Okay. Well, I was alerted to this question first, so I'm going to do this before I do chemist's question. Oh, it's you, Turtles. Okay. Let me, Prod, I don't know where your question is. I'm just saying. I don't see it in my Discord, and you didn't add me, at least, in the other ones. All right, let's see how we're going to do this. Let's open that. Great. That's great. Oh, you know what? We don't really need to have them both up at once. So this is a vocab and context question. So I want to talk about the way I approach these and the way you really should approach these on the test. SAT or ACT, it doesn't really matter, to be honest. All right, so here's the question. As used in line 7, curiosity most nearly means. Okay, I'm going to get rid of that immediately. They asked about curiosity. Yo, Turtle, I did that QAS yesterday. Nice, Minkyo. Okay, so we're going to do chemist. Hey, chemist, can you copy in your... Chemist, can you copy and paste your question into the Discord as a question? Because it doesn't have to be a picture, but just copy and paste the text. Because I want to be able to put it up on the screen so people can see it. So chemist, and then we can maybe do day of stuff. We'll talk about that. It's the big day. And then we'll go back. So I switched to this text because the question says line 7, and then the word was curiosity, right? Hi, Ruby. Okay, we're replacing the word curiosity. Do not take the answer choices that you're given and plug them into, if Yex, what is your Discord? Oh, Rob Yex Pert. All right, thank you. Or unless that's mine, is that not mine? I don't care. Whatever. Put it in wherever you need to put it, where I can find it. Always, for these questions, ignore the answer choices at first. The answer choices all have some connection to the word curiosity, but 3 of them are going to be misleading. They're going to start bringing your brain into the direction of that connection between curiosity and what's most likely the wrong answer. So ignore that. You want to use the vocab you have here and the context you have here to try to come up with your own meaning of the word to replace it first. Then go back to the answer choices. That way you don't get misled. And it won't waste time, because you still have to check all the answers anyway. And you can eliminate answers much faster if you have your own ideas in your head already. You're going to have to do this anyway. So let's just read from the beginning, since I have no idea what's going on. The phenomenon of false memories is common to everybody. The party you're certain you attended in high school, say, when you were actually home with the flu. But so many people have told you about it over the years that it's made its way into your own memory cache. Is it cache or cache, Bird?
I heard cache.
Cache? Okay. Cache means something else, right?
Maybe.
Yeah, I think it does. Okay. False memories can sometimes be a mere curiosity. But other times, I'm going to move this mouse, sorry. But other times, they have real implications. Okay. This question is awesome because the context is really, really clear. You don't have to look at the big ideas. You have to understand them, but the big ideas don't necessarily define this word for you. We're trying to define curiosity. The way this sentence is set up gives us what curiosity means. Because, thank you, chemists. They say false memories can sometimes be a mere blank. But other times they have real implications. The way that sentence is set up demonstrates to us that we have 2 conflicting ideas. But other times they have real implications. So that means mere curiosity needs to be something like the opposite of real implications. So mere curiosity, just a passing interest. It's just a thing. It's interesting. That's it. It's just, and mere means just. And we're not translating mere. So I would say interesting. And I don't have to get the word exactly, but I need to have in my head an explanation of what's going on. So something that's not super important, that's not real implications, right? We're doing the opposite of real implications because that's what it is. Hey, Slayer Darth, how are you? We're good, or I'm good. Brady's hanging out for now, but he'll be back. Okay, so let's go back to here and see what we like. Concern is the opposite, right? Real implications is more like concern. So I don't like concern. Question, maybe. It's just a question. C, oddity. Yeah, it's a mere curiosity. It's a mere oddity. It's something that doesn't matter. And oddity doesn't have import to that word. Wonder. I don't think that's what it's going for. Now, these memory things could be a wonder, but that's not how they explain them beforehand. And then afterwards, it's not the wonder is not the opposite of real implications. I think oddity works best here. I also might be wrong, but concern is definitely wrong. We're not asking a question. A question is not the opposite of real implications. Wonder might be okay, but a mere wonder doesn't really work. Mere oddity makes much more sense to me. So I would put C. Does that approach to these vocab questions make sense? The approach is way more important. I used the context. I didn't use my understanding of the word curiosity. I used my to an extent I did, because it helps a little, but that's not where you start. You need to start with the context, because the context is not going to mislead you. That's what the context is. It's vocab and context, not vocab. Okay. Mere indicates slight or minor. There you go. Thank you, Slayer. Okay. If you can't find a Discord, how do you expect to pass the SAT? Okay. That's kind of funny. Let's see. So we're in math for chemist's question. Okay, Dimitri's doing some stuff here. Dimitri is helping to plan a school talent show. You're scared. Taking the SAT on Saturday. Who's taking the SAT on Saturday? Not Kuzi. It's very sad, not Kuzi. It's very sad. Okay, so we got this thing here. Dimitri, I hope I can answer this question. I have no idea what this is from. What would you do if you don't know the context, what the key portion of the context is? Okay, let me do that first before going to this. Then you're going to get the question wrong, probably. It's not about, you don't have to know right off the bat, but you're looking for the way things are set up that you know. And I know that was an unhelpful thing to say, but like there is a way to go about these questions, and if you can't figure it out with that way, maybe you can do something else, like just using your understanding of the word, I guess, and then saying what kind of works in this whole passage. But you're thinking about several different things. I think most importantly, general context helps you. Okay, so let's write these down. We have general context, which is also a very vague thing, so great. Then from there, you have sentence structure. I think sentence structure helps enormously. In the sentence we just had, it said it's curiosity, but instead sometimes it's something else or something like that, right? So it had the word but in there, so it created contrast. You must get a good grade. Yes, very good, very good. So you must look for contrast, you must look for similarity, you need to look for the level of ideas, you need to look for, level of ideas is more for the transition questions in the writing and English sections, so ignore that one. But contrast is super helpful. What was I going to say? Dang it. Literal versus metaphorical. That's super important. If the word distance can sometimes be metaphorical, a lot of the times it's literal. So you have to be wary of synonyms of your original word, but they are literal synonyms instead of metaphorical ones, and you're doing something metaphorical. So the word foundation, for example, can be metaphorical. It can also be literal. You have to keep in mind what option it would be depending on what you're describing with that word, and then you just have to see if that works. And these can be very, very hard questions. The more you read, the more you're comfortable with these things. This is a gut feeling question type of thing, but to help your gut feeling, just like any other question, use the context. Okay, let's do this. This guy right here. So the last thing I wanted to write, 1, 2, and the last one is literal versus metaphorical. Okay. Do we still need to do this, or has it been answered? Chemist, do you want me to still do it? Say no. Say no if you don't want me to do it, but I'll begin. Brady's coming soon. In most cases, you can just work out what is being conveyed by highlighting a few keywords. Yeah. But like keywords for different people mean different things, and you can get different ideas from them. So you do have to make sure you understand everything. Okay, so chemist. Dimitri is helping to plan the school talent show. Great. Each performer of the talent show has 6 minutes for his or her performance, which includes transition time between performances. Okay, so we don't have to worry about transition time. It's included in those 6 minutes. If the introduction of the talent show is 24 minutes long and the entire show, including the introduction, will last 150 minutes, how many different performances can the talent show accommodate? Okay, this is a building equations question. The SAT loves these. About half the time on this test, you are either building an equation or interpreting an equation. And then most of the other time, you're solving an equation, and you're doing that with those questions as well. So this is a building equation question. You're going from English and these ideas, and you're logically putting them into math, which is just logic anyway. So let's do this. We are trying to get to a 150-minute talent show. That's how much time we have. What do we not know? We don't know how many performances there are. So let's say that's P. We don't know how many performances there are. But how long is each performance? 6 minutes, right? So we have 6 times P. That has to be 150. But we also need the introduction. The introduction for the show is 24 minutes long. So it would be 6P plus 24. Does this idea make sense? You have 150 minutes here. You have to get to 150 minutes. The way you do it is with the intro here. Solved it, found it on Brainly. Great. I'm glad you solved it. So this is a building equations question. Look for your equal sign. The equal sign is learning. Very good. I don't know what... oh, that's the sarcasm thing, right? Okay. I don't know what you guys are talking about right now. Does this make sense to you, chemists? Do you want me to clarify anything? Are you happy? Did someone just join the Discord? How did you get the 6p plus 24? Okay, so we are trying to figure out how much time we're going to take, right? So we have a certain number of performances p. So p equals number of performances. Each performance is 6 minutes long. So if you have one performance, you'll have 6 times 1. Of course, it would be 6 minutes long. If you have 2 performances, you have 6 times 2 performances, so that'll be 12 minutes long, right? The 150 minutes includes 24 minutes. Yeah, so Slayer Darth is saying the same thing. So we're doing 6 times p because it's 6 minutes per performance. So if you have 10 performances, it would be 60 minutes, which this math does. And then we have to also add 24 minutes. The 24 minutes is that intro. So we do 24 minutes, and then we have 6 minutes per performance. And then we can solve for p to figure out the number of performances necessary to fill up this whole thing. So to solve it, we would just subtract 24 from both sides because we're trying to isolate p. And we get 126 equals 6p. And then 126 divided by 6 is 21, I think. So p equals 21. As Slayer Darth said. This problem in particular, just like all the other problems we do here, isn't that important. It's the approach. So we know that we're trying to solve for a variable and we're given context. That context becomes an equation that includes the variable. I like using a variable that tells me something about the actual context. Using the variable x is totally fine. That's what we're used to. I like being used to other variables, and I like ones that keep me in the context in my brain so that I'm not starting to move away from what's going on in the question. Okay. I'm going to move on to day of stuff while I look at, to see if we have more questions, and it seems like we do. So, day of stuff. The day of, you want to bring all the stuff you got to bring. So calculators, bring extra batteries for your calculator. If you have an extra calculator, bring that too. Bring a snack, one without labels, I think. You can eat it right beforehand. Most proctors will allow you to have a snack. I think possibly the rules say that you can't, but you should be fine as long as it's not like a candy bar that has a wrapper. Like an apple, most people will let you have an apple. Bring water. Again, labels are an issue. Thanks, I understand it now mostly. I don't know how to start the questions, but then I understand them. Gotcha. Okay, we'll talk about that in a sec. So water, apples, whatever else you like to eat. What is the recommended snack for the SAT? See, Roby, now I know you're being sarcastic. The recommended snack for the SAT is Nerdish crackers, which are crackers made out of, no. I feel bad about making jokes without Brady here. I was gonna, and I don't know if it's acceptable, and he's gonna get mad. You know what? He's not gonna find out because he's not gonna watch this stream later. Nerdish crackers are made out of flakes of Brady's skin. Let's go with that. Yeah. So those are good. They're pretty salty, but surprisingly tasty. Bird.
Yes.
I'm gonna come clean. They asked what the best snack for the SAT is, and I said
Human flesh.
Well, similar. I said Nerdish crackers, which are made out of flakes of your skin.
My skin.
Yes, specifically your skin.
What do we use your skin for? Because we've also harvested your skin. What is that going into?
Warmth.
Of who?
Mine.
Your warmth.
Yes.
See, we harvest your skin, and then you take it and you make what? A thin skin layer?
My intestines always fall out without my skin,
Yeah.
so I gotta keep them in.
Right, but we took, what, I don't know, like 1% of my skin mass, and that's what we use to make Nerdish crackers. We've taken up 1% of your skin. I don't think it's enough to keep your intestines in. You've been using it for something, but you haven't told me what. Up until this point, I thought that it was both of our skins that ended up in the Nerdish crackers.
No, it was only yours.
So what else are you putting into there? Because mass-wise, it doesn't make sense if it's just my skin.
I have to put in a lot of water because your skin is so salty.
Right.
Yeah.
Very good.
As I've gotten older, I've become more appreciative of the importance of a balanced diet.
No.
As I've gotten older, I've become more appreciative of the importance of a balanced diet.
I've seen eating more fruit, in particular. Ben. I recognized on my own that Roby Expert when they said the little black and white Eleanor Roosevelt person, that's sarcasm. Remember,
That's what that means.
we learned that last week.
Okay.
Let
me see
So let me pull up. It's 25-ish. I have a child at 6:30, so I will have to go soon.
Very soon.
Look at all these questions, Bird.
Yes.
Not koozie. Da 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 doo doo. This question looks fun. Oh, that's not what I wanted. All right. Okay. Keep asking your questions. I will answer them, then I will hand off to Bird, who will answer them. Brady has acting chops. Oh, yes, he does. Absolutely, he does. That's exactly how you read overly formal text. That's good. Wow, I can't read this at all. Can you guys read this stuff? I'm going to read it over here. An environmental biologist recorded the numbers of snail eggs in the first clutch. Oh, so snail eggs are measured in clutches, or grouped into clutches.
Yeah, you don't know that?
No, did you? Stop it, Brady. Laid at different temperatures as shown in the histograms to the left. At 22 degrees Celsius. Okay, so let's just check out these graphs here. So it looks like we have the number of eggs on the y-axis and then just the temperature on the x. Okay, so that's really easy. So clearly, in general, y-axis is your dependent variable, x-axis is your independent variable. That would make sense, seeing as temperatures don't change based on how many snail eggs there are, unless you're in a very confined space, I guess. Okay, let us read the question. At 22 degrees Celsius, the snails laid a mean of 49 eggs. At 22 degrees Celsius.
Right back.
What? I'm actually confused right now. So we have number of eggs, or number of snails. What? Oh, okay. I misinterpreted these graphs. It looks like the number of snails is here. So that's kind of stupid. The number of snails is on the y-axis, and the number of snail eggs is on this axis. That's very strange. Brady, come here, because you're going to have to take over for me for this question. And I might be interpreting it wrong.
What havest we?
Okay, it's a very strange graph, because they talk about snail eggs and temperature. But the y-axis is the number of snails, and the x-axis is the number of snail eggs. There is no change in temperature, it looks like. It's only at 22 degrees Celsius.
And then a 25 at the bottom.
and then 25 at the bottom.
Right.
So I at first misinterpreted the way they worded the question. I thought they were comparing number of snail eggs to temperature. It's not so much that. It's number of snails to number of eggs, and then at 2 separate temperatures. And then they're asking about at 22 degrees Celsius, the mean is 49. So that's the top graph. It has a mean of 49.
Okay.
At 25, they laid a mean of 31, which statement best compares the standard deviation of the numbers of eggs.
Okay. So
Oh, okay.
the spread of the top one is more.
Yes. That was an easier question than it needed to be.
Now wait a second though. If you're thinking of standard deviation because it's spread from the mean, you have outliers on the top graph, and outliers bring the mean up, higher than it would be normally. So the mean will be a little bit higher. But actually that means that the spread is going to be higher.
More.
Right.
Yeah, so it would be the green answer, as usual.
Yeah. Because if the mean of this thing up top is more to the right, then all the bars on the left, which are where most of the data is, they're further away from the mean.
Have a good night, everybody.
This bottom one here doesn't have as many outliers. So the mean is a better indicator of where most of the data values lie. So focus on the outliers. No. It's more, these graphs here are not symmetric. They're skewed, is what it's called. Where most of the data points are on one end, and then you got this tail that goes out to the end. And if you look at the tails of both of these, this one up here has this tail that goes out further. And when you have a tail that goes out further, it means that your average, your mean, is pulled out that direction towards the end of the tail. Either way, standard deviation, just think of the word spread. Which one has a greater spread? These have values that go out super far away, so they're a little bit more spread out. That's the simplest. It's not exactly the totally technical way to think about this. Do not calculate. That's absurd, Rob the expert, and you know that. You're not going to calculate the standard deviation of this. However, yeah, that one's a little bit more spread out than this one down here. Because this one down here has a ton, like way more bunched up in these last 2 columns here are where most of the data lies. And then up here, you got to go 3 columns over to find that chunk of data, which means that they are a little bit more spread out. So bigger spread means bigger standard deviation. I have not yet looked at the rest of this stuff. Let me see what kind of questions. How are we doing, guys? Are we doing good? I've been worried about you all collectively. What are standard deviation again? Standard deviation, it is a measure of spread. So when you have a list of data values, like let's say, let's say that you go around and you measure all the women in the US that are 40 years old, you measure their height. Don't measure their weight, they're not gonna like that. You measure their height. They're probably gonna cluster around an average, where most women are close to an average. And then there's going to be women that are way more than that and women that are way less than that. And there's not going to be as many of them. So what you end up getting is called a bell curve or a normal distribution. Where this right here is your mean. Most women, NA diet, am I right? New Atkins diet. They made a new Atkins diet? Oh, that's awesome. Shift that to the right. Well, we'll get to that in a sec. This right here is the symmetric normal distribution. Your standard deviation is a measure of where most of the values are. So like if you pick a random value in this, and I'm not going to be exactly technical because the actual explanation is quite long, but they don't need you to calculate standard deviation in these tests. They just need to have you. They just need you to have an intuition of what it means to have a larger or smaller standard deviation. So if you pick a random value, you might pick this one right here. You might pick that one right there. Every now and then you'll get one out here, but most of them will be somewhere around clustered around the mean, because they're not that spread out. Whereas if you had something like this thing here, the data values you're going to get are going to be a lot more spread out from the mean. So this one is going to have a larger standard deviation. It is a measure of spread. The larger the standard deviation, the larger your data is spread out. I mean, I can give you kind of like a proxy for what it means. I need to grab one sec. I'm gonna show you what it's called the absolute mean deviation, and it's not the standard deviation, but it's something similar that you could think about. Okay, close, and then. Okay, so we had like a list of numbers here. So let's say we had 4, 7, 7, 9, and 10. First thing you would do is you'd find the mean. So you'd add up all the numbers and divide by 5. So we have 4 plus 14 is 18, 28, 37. 37, yeah. So we have 37 is our mean, and then, I'm sorry, it's our total. Divide by 5, and you're going to get 6.4. 6.4 is going to be your mean. So if you want to figure out, okay, how far away are each of my data values from 6.4? You do a subtraction. You'd say, okay, 6.4 minus 4. 7? Roby expert. What do you mean by 7? And questions for stream. Okay, thank you, Chemist 1902. 7.4. Yeah. Thank you. You're right. It's been a long day. 7.4. Very good. Very good. The only one that's ever perfect is Levi. He makes no mistakes. So the differences between all of these, 7.4 minus 3. Sorry, 7.4 minus 4. That's 3.4. So these are all the x values. And right here, we're going to have the correct indication, or the correct marking is x bar. That means the mean. So all of these are going to be x minus x bar is what this is going to be. And I'm going to put absolute value around it because I don't want it to matter if the deviation is negative or positive. Deviation means how far you are away from the average. So this is 3.4. This is 0.4. This is 0.4. This is going to be 1.6. And then this is going to be 2.6. It's a weird 2. That's a 2.6. So if you take the average of all of those are your deviations from the mean. If I take the average of all of those, which I'm going to do right now, we have 3.4 plus 0.4 plus 0.4 plus 1.6 plus 2.6, and divide that by 5, you're going to get this. Mean deviation equals 1.68. And actually, it should be absolute mean deviation because it doesn't matter if they're above or below. So what this means is that if you pick a random data value from this list, chances are it'll be about 1.68 units away from the mean, okay? That's absolute mean deviation. So it's like on average, how far away is a data point from the mean of your list? You can think of this like standard deviation. Standard deviation is a little more involved as to how they calculate it, and it's used for calculating things like percentiles. It's a long story. You don't need to know it for this test. What you need to understand is that data that's more spread out has a larger standard deviation. Data that is not as spread out has a smaller standard deviation. We will be continuing now. Okay, so that was a Coos question. So we're going to go now to, we're going to skip the next Coos question. We're going to go to Pale Moon. Oh, Pale Moon. This looks like a fun one. This looks like a fun one. I'm excited about this one. I'm just going to crop it. Here we go. Just going to crop it. Quick little crop. Very good. Very good. All right, should we use programs in a calc on the test? Yes, you should. There is a little sub-channel on our Discord. You know standard deviation will be in the top 5% percentile. Ha, that's very good. That's very good. What do they do? Not koozie. Check them out. They do things faster for you. They do things like calculate the slope, midpoint, distance between 2 points. It's just a list of formulas on one of them. I put it all in the Discord on that calculator program channel with instructions on how to get them. It's either for TI-83s, 84s, or 84 pluses. You got to have one of those calculators. That's what the programs that I offer have on them. And just put them on your calculator, explore, see what they do. They do a lot of stuff. They do a lot of stuff, and the advantage to using them is they will do things for you faster. So you don't have to spend time. There's a systems of equations solver on there, which is pretty nifty. There's like, it'll calculate the greatest common factor, least common denominator. Sorry, least common multiple, which is also least common denominator. Greatest common factor of 2 numbers. If you give it like 3 sides of a triangle, it'll tell you what all the other angles are and what the area of the triangle is. Just, you know, fun stuff like that. And then it'll just have, it has pages and pages. And they allow them to test. Yes, they do. Tindoy, welcome.
It's good to see you. Yeah, they allow it on the test. There's a specific kind of calculator that you cannot have on the test with something called CAS, C-A-S, which stands for, I think, Computer Algebra Solver. This is where the computer can literally solve algebraic equations. Like when you move things around, divide on both sides, it does that for you. They don't want you to be able to do that on a calculator, that it does it for you. That takes all the fun out of math. So as long as you don't have that on your calculator, you're good to use programs. Totally fine. It's great. That was the kind of calculator. Well, you can't do that. They do check the models of calculator. They allow anything besides the calculators that have CAS functionality. Look on the website for SAT, if that's the one you're asking about. It's all on the website. Okay. Here we go. In order to fulfill a prescription for 200 milliliters of a medication at a 55% solution, a pharmacist must mix X milliliters of a 40% solution with Y milliliters of a 60% solution. What is the value of X? Oh man, this is fun. This is fun. Okay. So, I'm assuming here. Oh, okay, we got it. Okay, so let's define our two. You guys are asking about programs. Guys, it's allowed. They're allowed. Look at the policy. It's online. I'm not trying to make you guys get your test invalidated. Otherwise, that would be very bad. Okay, X is going to be, and this is important, it represents the amount of the 40% solution. Where we're going with this is a system of equations. All right? And Y represents the amount of, what is it, 60%. So you make a solution that has both of them in there. The new solution is going to be somewhere between 40 and 60% because it's a mix of these two right here. You don't add them, you average them. It's like if you have a pot of water that's 100 degrees and a pot of water that's 50 degrees, and you pour them together and mix them up, you're not going to get a pot that has 150 degrees of temperature. It's going to average. It's going to go between 50 and 175 degrees if you're mixing them in equal volumes. That's kind of what's happening here. There's no actual Y. There is an actual Y here. Calculator, I'll try your best. You work on your own if they don't allow a calculator, or be honest and try your best. And if they fail, I would fail. I just do what I can. Yeah, but they allow a calculator, so. Guys, I promise you, there are certain kinds of calculators you can't use, but they allow calculators. Make sure that the model you have is allowed. Most of them are, and they also allow programs. That's all I got for you. Okay. So one thing we know is that we're trying to make 200 milliliters of the final 55% solution. Okay? So if we just add the two amounts together, X plus Y should give us 200. That's our first equation right there. That's just the amount equation. Certain number of milliliters of X, certain number of milliliters of Y will give us the final amount, which is 200 milliliters. And the second equation has to do with the amounts here. And this is the tricky part. So the medication here. Okay. Wait, will programs help us find factors for polynomials? Let me think, the things that I have. Quadratic formula will do it for you. So there's quad on the programs that are on the Discord. Quad is part of it, and you put in your numbers for quad. It'll tell you all the zeros, whether the discriminant is positive, negative, zero, what the vertex of the parabola is, things like that. If you want to find an easy way to find factors, graph it. Graph it and find the x-intercepts. Make sure you know how to do that in your graphing calculator, because that's a pretty quick way. It'll only let you find real intercepts, like real x-intercepts, because there might be complex zeros that don't show up as x-intercepts. Your calculator can't help you find that. But anyway, so there's some medication in here, and in that final 55% solution, 55% of the solution is that medication. Okay, so let's think about that for a sec. What does that mean? So 55% of the final 200 milliliter solution, if we multiply those together, we'll get the actual amount of medication in that. Typically solutions are something and water. A lot of solutions we make are something and water. So that means that 55% of 200 is the medication and 45% is most likely water. So if we take 55% of 200,
That's going to be 110. 110 milliliters. Okay, now I can combine drugs. There you go. Yeah, you love that. 110 milliliters are the actual amounts of drug in the solution. So we have the overall amount equation. Now we need to do the amount of drug equation. So this is total amount. And then we have the drug amount. The drug. Ooh, drugs. The drug amount. The way to find the drug amount is what we just did here. If you take 40% of the X solution, which that'll be the amount of actual drug, and you add that with 60% of the Y solution, which will be, again, the amount of actual drug in Y, you will get this right here, 110, which just for now I'm going to write like this. Here we go. Here we go, here we go. Let me get rid of this for a sec. So this is your other equation, and this is what gives you a system of equations, okay? This has got to make sense here. This gives you the actual amount of drug. The amount of drug you get from the first two solutions added up should give you the amount of drug that you get from the second solution. So we have to do either substitution or elimination, one of them. And I'm going to opt for, let me think about this for a sec. I'm going to opt for elimination. I can't believe how simple this is. We learned this concept in pre-calc and also had an SAT prep and always thought they would combine the two equations without clearly separating them like this. Oh. Yeah, no. You got to separate them first. Otherwise, if it's just one equation, or at least, I mean, we're going to combine them in a sec because that's what substitution and elimination do. But I could never think through this with just one equation from the very beginning. That would be, wouldn't like that at all. All right, I'm going to multiply everything here by 0.4. So this equation is going to become 0.4x plus 0.4y is equal to, let's see, 2/5, 400 divided by 5 is going to be 20 times 80. Did I do that right? Half of that is 100. 10% is 20. Yes. Okay, and then we have this bottom equation right here. And now that my x's have the same coefficient, I can do my subtraction. Okay, the x's will cancel out. The y's will become negative 0.2y is equal to, and this will become negative 30. So first off, I can make these positive because they're both negative. So divide by -1, multiply by -1, whatever it is that you like doing. Whatever. Okay. This is 1/5. So to get rid of 0.2, you have to divide by 0.2, which is the same thing as multiplying by 5. So I'm going to multiply both sides by 5. And y is equal to 150. Now, if I were strategic, I would have done this the other way because they want the value of x. I mean, I'll tell you the value of x. It's 50 at this point. If they both have to add up to 200, and we already know that y is 150, x has to be 50. If I was strategic, I would have eliminated the other way around, so I'd be left with x, and I wouldn't have to solve for y. But in this case, it takes a second to find that x is 50. So finding either of them will take roughly the same amount of time. But sometimes it is better to think for a second about how you want to eliminate the variable you don't want. So if I had multiplied this equation by 0.6, I could have eliminated y and gotten x from the very beginning. Anyway, any questions about this? Any questions about this? Turtles, I'm glad that it is simple now. Ah, yes. I would still need y, so I don't OD. Ha! Very good. That's extremely good. Well, y would probably make you more likely to OD because it's a stronger drug. It's got 60% of the drug in it. Whatever you think of that, you can continue thinking of that like that. All right, so that was Pale Moon, and then, okay. Oh, we got a lot of people here. Minkyo, we're gonna do one of yours, and what is it? It is number 1. Number 1. Okay. Here we go. Here we go. Dinosaurs. Love them or hate them, They were there. They were dinosaurs. That's what they always say about dinosaurs. Okay. All right. Dinosaur disaster. Roughly 65 million years ago, dinosaurs, along with 65 to 75% of other plant and animal species on Earth, became extinct. This massive wave of... Anyway, you get the picture. So, all right. What do our answers look like? We have dinosaurs with commas around it. That's answer B. Let me get rid of all this math. Okay. So we have no change, and no change has a comma after a go. So that is the first thing we got to think about. We have commas surrounding dinosaurs. We have commas surrounding along with, and then we have one comma after with. Okay. So one thing that I do know here is that there's a comma after Earth, which is very interesting. That comma is not underlined, so it's not going anywhere. So there might be something we have to do that reflects the fact that that comma is there. If I just read what's right before this comma, I have 65 to 70% of other plant and animal species on Earth became extinct. And that sounds great. The fact that there's a comma here separating that means that this thing here before is some kind of interrupting element. Because there'd be no reason to disconnect these unless this chunk here was not necessary. It was a non-essential. So we have something starting up here, and then we skip all the non-essential stuff and we go straight to became extinct. Otherwise, you'd never want to separate this two. This is a verb right here, and this stuff up here looks to be like a subject. 65 to 70% of other plant and animal species on Earth became extinct. So that tells me there has to be a non-essential, an interrupting element in the middle of the sentence, and the question then becomes, where does that start? Where does it start? Because if we can figure out where it starts and we can remove it, we'll know where the comma is that's supposed to be there. That first comma. Every interrupting element has a comma before and a comma after. So let's see if we can figure this out. Roughly 65 million years ago, dinosaurs along with 65 to 75. Okay, the way it's written, we only have one comma, and that's a go. So that would be, right now, the default comma to start the non-essential. So if that's the case, I should be able to read everything but just not the non-essential, and it should make sense. So I would say roughly 65 million years ago became extinct. Not okay. That is clearly not where the comma is supposed to go. So then we have B. We have ago, comma, and then dinosaurs, comma. And here we get to an interesting thing about commas. Commas do a number of different things. We can talk about them if you want. But commas themselves, even if they're doing different jobs, look the same. A comma that's a listing comma, a comma that is a comma fanboys comma, they all just look like commas. You have to use your brain to figure out what in particular that comma is doing. So some students would look at answer B and they'd say, oh, there's commas that's surrounding dinosaurs, which makes dinosaurs an interrupting element. So I should be able to read this without dinosaurs, and that should make sense. Let's see. Roughly 65 million years ago, along with 65 to 70% became extinct. Like, okay, that doesn't work. Dinosaurs is essential. So we're going to need to keep it, so B doesn't work. Well, just because those commas around dinosaurs are quite close to each other doesn't mean they're supposed to be paired together. There's another comma down here. You might need to pair one of those commas in B with this comma down here. All right? So it might be that one. We'll come back to that. Let's see if we can roll out the other ones. So with C, along with. At this point, we probably should just try to figure out what the non-essential is. We know there is one here. So roughly 65 million years ago. Think about that sentence right there. There's a pause built into that. If you just read this to someone, you would pause right there. Down chick, NBA young boy. Very interesting. Roughly 65 million years ago, dinosaurs along with blah, 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 blah. There should be a comma after a go because that's what's called an introductory element. It is, you can take it out. It's a non-essential. It tells us something somewhat important, which is when this is happening, which is why we want to keep it. But it could be removed from the sentence, and we would still have a sentence. So I do like having a comma after a go, and there's two answers that do that, which are A and B. We've already talked about how A doesn't make sense, so the answer here is going to be B, but let's talk about why that makes sense. The comma after a go in B is ending that first introductory element. The comma after dinosaurs is the one that should be paired with this one right here, getting rid of all the stuff in the middle, because then it would sound like this. Roughly 65 million years ago, dinosaurs became extinct. That is the original independent clause. So that second comma is the one that's paired with this comma right here. That is why the answer is going to be B. All right, we need two commas. They don't have to do with each other. One of them has to do some comma stuff with that. That is what is going on here. So whoever asked this, I think it was Minkyo. Does that make sense? Does that make dollars? Does that make rupees? Does that make kroner? Do you like it? Do you not like it? Plus, if the passage is dinosaur disaster, they're probably introduced with dinosaurs, not the 65 to 70%. Yeah, very true. Yeah, it's mostly about dinosaurs. That's a good point. That is a good point. I mean, you can use intuition like that, and that will get you there a lot of the time, but you should also have sort of the mathematical laws of grammar down so that you can tell this is the interrupting element. You know, even if I didn't know the title of this passage, I'd be able to figure this out. But that is a good point, Turtles. That is a good point. Okay, so that was Minkyo. And then we have chemist. And then we're going to come back to all the other questions. Let's see what we got, chemist. Let's see what you got for us. Okay, this is looking somewhat familiar. No, it's not. It is not the same thing we did before. Okay. This looks fun. Let's see what we have here. An umbrella sprinkler is positioned on a ceiling. All right, so like when they have those fire sprinklers at a ceiling at a point whose x-coordinate is 0, as seen on this graph. Negative values of x indicate distances in meters to the left of the position of the sprinkler, and positive values indicate distances to the right. All right, the picture here is doing pretty well. It's basically, if you're looking at the sprinkler, the x-axis is the floor. The sprinkler's up there, and it sprays to the left and to the right. The path of water from the sprinkler can be modeled by that quadratic function, where W is the height in meters at position x, which the following equivalent expressions displays the height of the ceiling as a constant or coefficient. Okay, and we're going to need the answers here because it says which of the following. So chemists, I'm not sure if you put the answers here. Yeah, chemists, we're going to need those. We're going to need those. I mean, I'll show you where to start here, but it's not going to be possible to finish this because it's asking which of the following. However, we know we need to find the height of the sprinkler, because it wants to see that number in the next expression used as a constant or coefficient. So either it's before a variable or it's just hanging out by itself. We need to see the height of the sprinkler. So we have to figure out what is the height of that thing on the y-axis, which is W in this case. And there's two things going on with that height. Number one, that is the vertex of the parabola. The sprinkler is at the top. So we could think of it as the vertex, but also the vertex happens at a very special spot. That is on the y-axis itself, so it's a y-intercept. So if we find the y value when x is 0, that's the height. You're on the y-axis when x is 0, okay? If you want to find the y-intercept, okay, put the options Discord. Cool. We'll take a look at that in a sec. I'm on a roll right now. If you want to find the y-intercept, just plug 0 in for x, and you'll end up on the y-axis at whatever point crosses the y-axis. So right here, we're going to take w of 0. We're putting 0 in for x, and that's going to get us, let's see, negative 1/4 times, so x is 0. So this is going to be 0 squared minus 12. Okay, so 0 squared is just 0. We subtract 12, that becomes negative 12. So we have negative 1/4 times negative 12, which is going to give us positive 3. Like Turtle said, we need to see positive 3 in the answers that chemists just posted. and that is the one we'll be able to use. All right, let's see what we got here. Here are the answers. All right, it's A. A is the only one with 3 in it. It's used right now as a constant because it's by itself. If it was before an x value, it'd be used as a coefficient. But those are the possibilities for how a number could be used in an expression anyway. It could be used as a constant or coefficient. So just if you see the number show up in any format, you got a chemist. Yeah. Do you have a tutorial for programs? Nakuzi, honestly, if you put the programs in your calculator, like have you done that yet? And if so, just play around with them. You'll figure out how they work. They're pretty self-explanatory. Do you mean putting them on your calculator? Is that the tutorial you want? Or is it when you actually have the program? There are programs in the Discord that we posted. All right, we're going back now. This is Coos or not Coos, one of the two. No one's exactly sure. Okay, putting them on. Yeah, not Koozie. I think check out what Chemist just posted. Did I not put instructions on the or like a link to a video? I think the instructions. I gotta check what I put on the Discord. You have to download a program from the internet. It's called TI Connect, and that's if you have a TI calculator. You can't. These programs are specifically for TI calculators, and you also need to have the cable for your calculator. Because this calculator program is like hundreds and hundreds of lines, so it's not one where you just copy it on yourself, line by line. You have to download it with the cable. Oh, I posted down chick and be a young boy. Yes, you did. It's very important that you did that. Oof. I'm going to grab a little bottle of water. 1 second. 1 second. I now have said bottle. I am now back. I don't know about a cable. Gotta find a cable. This water's crunchy. Yeah, I like my water crunchy. It's got gristle. Who in here loves rap music and is addicted to it? Chemist, I think you are. So I do not know. Oh, that's what you just posted. It's not a tutorial. I understand what happened. Okay. That's a song. I see. Very, very helpful. Very helpful. All right. Sediment in water lowers the intensity of light shining through the water. That's unfortunate. The following function C gives the light intensity in candela per square meter of light at a depth of d meters in a particular body of water. Which of the following equivalent functions shows the approximate percent change per centimeter as a constant or coefficient? All right, all right, all right. You need to know what percent change looks like. You also need to know the formatting of exponential growth and exponential decay. This is exponential decay right here. That's what this is right here. Okay. If we're going to multiply 9,300 by 0.8 to the d, think about what an exponent means. An exponent means repeated multiplication. So if we were going to multiply it by 0.8 to the 1 or by 0.8 to the 2, this would be times 0.8 times 0.8. You're going to be multiplying by 0.8 a certain number of times. So every time you multiply by 0.8, what happens? Well, does it get smaller or bigger? It gets smaller. What language is D written in? Like this one right here? Or not sure what you mean by that. Something gets smaller. If you multiply something by 1, it stays the same. You multiply something by anything greater than 1, it goes up. You multiply something by something, that's exact. Yeah, that's right, Nakuzi. Yeah. You're taking 80% of something. That's what happens when you multiply by 0.8. You're taking 80% of something, which means you're knocking 20% off the top. So it's going down by 20% each time. Yes. So percent change here is 20% downward, and we want to see that as a constant or coefficient. So it looks like we see 20% in A. It looks like we see 20% in B. When I say that, I mean the 0.2. That's 20%. C, let's see what we have here. 0.002.
And then, oh, okay. Okay, we gotta be a little bit more careful. Okay, yes. Let's look at our units very carefully. The function C gives the light intensity in candela per square meter. But what they want is the percent change per centimeter. Per square meter of light at a depth d. Yes, d meters. I'm sorry, that's the important part. The function right now has d in terms of meters, but what they want is the percent change per centimeter. So it is 20%, but that's per meter, and we have to change that to what percentage is that per centimeter. So we're going to have to do a unit conversion there. Okay, I should have paid more attention. Is it worth calculating that just to know the centimeters must be lower than 0.2? That's a good point. Yeah, you can get rid of A and B. With D, you have 2 times 10 to the negative 10th, which is tiny. I think you could rule that out because it's crazy. But I will say, let's just show how to do the dimensional analysis real quick. So we have 20% per meter. And we want to change meters into centimeters. That is how you would cancel out your meters. Meters on top, meters on bottom. What you'd end up with is 20% divided by 100. And that is going to give you 0.2 divided by 100, which is going to shift that decimal back 3 places. I'm going to put it down here. 0.002. Yeah. Oh, that's true. They're on the concept of lower. Yeah, but I think your intuition is right. And as long as you know that meters and centimeters aren't too far apart, D is crazy. D is so small. So, like, you could probably rule it out that way. But yeah, the units here, tricky. Very tricky. Sometimes in the questions I see, when there is a unit conversion that needs to be done, they'll say something like approximate percent change per centimeter, but the per centimeter will be in italics, which will be like, hey, look at me, I'm in italics, so something special is happening here. But not all the time. In this case, yeah, this was really tricky because, I mean, with A, you got this really, really long 0.0000. I mean, like, I don't know where really that comes from. It's wrong, so, like, there is that. Anyway, we're gonna keep going. It is hot in here. It's hot. Here we go. This is a pale moon question. Let's see what we got here. Okay. Ooh. All right. Here we go. If 0 is less than or equal to a, which is less than or equal to b, and a plus b squared minus a minus b squared is greater than or equal to 9, what is the least possible value of b? Interesting. Interesting, all right. If you're like me, you're looking at this and you're saying, like, I don't know where this is going to go, but I could probably take some bites out of it. Like, this thing right here. There's a couple things we could do with that. We could square things. We could see that it's a difference of squares pattern. I don't know. But the important thing here to first see is that A and B are both positive because they're both greater than 0. B is greater than A. B is greater than A. B is bigger. We do have some variables in the question. So maybe we could put our own values in here. That might be true. Maybe we couldn't. We might not be able to because it has to be greater than or equal to 9. We'd have to find. Yeah, it might be worth it to try putting your own values in for A and B, but I can tell you, you're going to get to a dead end. You might have a possible value of B, but they're asking for the least possible value of B, which is a little bit trickier of a question. So I would say the first thing I notice is, like, let's just FOIL and see what happens. Just FOIL and we can see what happens. So a plus b squared. That is going to be a squared plus 2ab plus b squared. And then we are subtracting, I'm going to put this all in parentheses. We are subtracting the next thing, a minus b squared. And that is a squared minus 2ab plus b squared. And that is greater than or equal to 9.
Get a better marker. Give me a good marker. Give me a good marker. Something that's like totally new and fresh. Is that good? That's pretty good. Oh, I need a fan back here. This is gross. And you guys are probably like, wow, he smells terrible. Guy smells terrible through the screen. Oh my god. So, can we eliminate some things here? Yes, we can. A squared minus a squared. Those are going to cancel out. B squared minus b squared. Those are going to cancel out. So we have left here, we have 2ab. I wanted my orange one. Why did I not do that? Yes, turtles, there is a difference of squares here. We're going to see if that's what we need to do. Minus negative 2ab, which is plus 2ab. That is greater than or equal to 9. So combine these, we get 4ab is greater than or equal to 9. Can we go anywhere from that? Well, I guess we can divide by 4. We can go ahead and do that. So that means AB is greater than or equal to 9/4, which is 2.25. Okay. And then B is what we're looking for. So let's divide by A. If we want to get B by itself, we divide by A. B is greater than or equal to 2.25 over A. And at this point, we can't go anywhere. We know that B can be greater than or equal to that, but we don't know what A is. Okay, have a good night. I'm going to finish my last minute homework for this evening. I'm going to be chilling. Very good, chemist. Go do some chemistry. That seems to be what you like doing. Okay, this didn't get us where we wanted to go. There's nowhere we can go. We got a little bit of a dead end. It was worth trying. The next thing to notice is that we have a difference of squares pattern. A plus b squared minus a minus b squared. But the whole thing is a difference of squares. Difference of squares is when you see this pattern here. X squared minus y squared. A squared minus b squared. Essentially, it's something squared minus something squared. You know, you see something like x squared minus 16. That is a square minus a square. And you get x plus 4, x minus 4. It's that plus minus pattern. We have that here because we have a plus b squared, so that's something squared minus something else squared. So it is a difference of squares. So it's just interesting because we have an expression inside each thing that is being squared. So we're going to have to be very careful here. So here we go. We're going to call, okay, so we have a plus b squared minus a minus b squared. So it's this squared minus that squared. And so the way that you usually do that, if you think of this as like x squared minus y squared, that gives you x plus y times x minus y. In this case, x is this entire thing. It's a plus b. And then y is the entire a minus b. So we would have to do, this is our x value. So we have a plus b plus a minus b. And then we are multiplying that by a plus b minus a minus b. And let's see where that gets us. So that's, b's cancel out. We have 2a. In here, a's cancel out. A plus b, so the minus a, then we have 2b. Oh. Interesting. Okay, okay. What I'm seeing here is it looks like we're getting back to the same place we were at before. Which we are.
there's got to be something that we're missing here. Okay. 0 is less than A, which is less than B. So B has to be greater than A. And they're both positive. What is the least possible value of B? So if this is your... That's the only restriction on B. B is positive, and it has to be greater than or equal to 2.25 over A. Okay, well, the very first positive number... Okay. Okay, I think I see what's going to happen here. Let's graph this. It's going to look like this. We're looking for the least possible value of y. So 2.25 over x, that's a rational function. It is a rational function. It's got an asymptote where x is 0, which is vertical on the y-axis. So there's an asymptote here. That's an asymptote. And then it is a, I don't know how much you guys know about rational functions. Oh, jeez. There'd be a horizontal asymptote at y equals 0. This is a very tricky question. I don't think you'd see it on the ACT or SAT. There's a horizontal asymptote there. Y has to be greater than this thing. All we care about is where y is positive. Okay, so if we just start thinking of some values, table of values, here we go. When x is 1, y is 2.25. When x is 2.25, y is 1. I'm going to put those on there. X is 1, y is 2.25. When when x is 2.25, y is 1. What if it's equal to 9? Is that way you have to think about this? The least possible value. If it can be greater than 2.25 over x, what happens when it's actually equal to 2.25 over x? At that point, you're on that line. But what's the... I mean, it looks like it's going to 0. I'm going to take 5 more seconds and look at this. This is very difficult. I don't think you'd actually see... I mean, no, you would not see this on the test. I don't know where this is from, but this is very tricky. Okay, really equal to 9. Both be negative, then they both have to be positive. They both have to be positive. All right, it's 0. Yeah, okay, it's 0. Like, if you think about it, x, if that was 9, b has to be greater than that, though. B is greater than A. What's this possible value of A? Yeah, all right, hey, forget it. I'll look at this later. You're not going to see this on the test. That is me giving up because it's hot down here. Whew, okay. Mikio's next question. What do we got here? Number 34. Sorry, guys. If Levi were here, he could do it. Okay. Apparently it's 1.5. Wouldn't have to be greater than the asymptote, though. Oh, that's so weird.
Oh, jeez, this is way too big. Wait, what is going on? Get me out of here. What is this? Okay. Oh no, okay. Full screen. There we go. Apparently it's 1.5. B has to be greater than A. If A is 1, B is 2.25. Apparently it's 1.5. Yeah, I'm not, where would 1.5 come from? If they were the same value. That's what it is. All right, that's what it is. Hold on. That's what it is. Here it is. We're going to do it. We got it. Not that. Get out of here. The thing that I forgot is that A and B could be equal to each other. A and B can be equal to each other. B is not necessarily greater than A. I just said that and I completely forgot. They could be equal to each other. If that was the case, let's look right back at this. 4AB is greater than or equal to 9. If they're equal to each other, which they could be, then A and B would be the same thing. So I'm just going to write this as 4B squared. Just 4B squared. I don't know how I didn't do this before. A would be the same as B, so this will be 4B squared is greater than or equal to 9. Divide everything by 4. B squared is greater than or equal to 2.25. Take the square root of both sides. B is greater than or equal to 1.5. The smallest it could be is 1.5. That is the answer right there. That is the answer right there. So you would have, that would be right there. Oh, and that makes sense. Oh my gosh. Okay, okay. All right, if you remember, B is your Y value and A is your X value. And B could either be equal to A or it could be greater than that. Okay, here's where that would be. So if I drew this line right here, this is the line Y equals X, which would also be the line A equals B in this case. Okay? Our Y value needs to be greater than our X value, or equal to it. They're equal right here, and if you want to find where Y is greater, that's all of this stuff right here. All of that stuff. So this part of the line is actually off limits. That is the smallest your Y value could be. All right. I feel much better now. Apparently, okay, yeah. That's what I forgot, is they can be the same value. Ugh, don't tell anyone, please. Back to Minkyo. Okay. Oh, it's okay. You made no mistakes as far as we're concerned. Turtles, you're so kind. You're a turtle, so I guess that's sort of what's to be expected of you. 'Cause turtles never hurt anyone's feelings. I mean, yeah, it was a large omission. It's a large thing that I forgot. They could be the same thing. Why did I forget that, turtles? Turtles, I just don't want to disappoint you. I really don't. You are why Levi and I started this whole thing. And it took a while to get you to watch, but now that we have you watching, it's just so painful to disappoint you because the whole plan, you're adults, it's okay. Thank you. Oh man, I'm an adult. That's strange to hear. You know, I used to be a kid. I used to be a kid, I swear. But then, I don't know, you just sort of, you stop being a kid. I teach kids that are like a decade younger than me. And that's a solid amount of time. So, I'm definitely not a kid anymore. But I'm definitely not old. I don't think I am. My grandparents are old. They're very old. They're in their 90s. They're so old. Hope they're not watching. No, they're not. There's no way. There's no way, and even if they are watching, they wouldn't be able to hear what we're saying. So there's that as well. So I think I'm pretty safe to take a couple jabs at my grandparents. It's the kid wreaking havoc in the Stanford lecture halls. Is that supposed to be me? I don't know. I didn't wreak a lot of havoc. Not a lot of havoc was wrought by me. That's passive. You don't want to say it. You want to use it active. I didn't wreak a lot of havoc. Not a lot of havoc was wrought by me. Active versus passive. Subject, verb, object. Not object, verb, subject. It's so hot down here. What do we got time-wise? All right, we got a couple more minutes. Costume curators in the digital age. Ooh, robots, digital age. Bridging art and popular culture, costume exhibits have enabled museums to attract media attention and new audiences. Such exhibits are created and overseen by costume curators. The term costume curators refers to professionals who oversee the... Oh, okay, hold on. We're back. The term costume curators refers to professionals who oversee the acquisition, maintenance, and display of clothing collections at museums. And 34 says, which choice most effectively combines the sentences of the underlined portions, at the underlined portion? All right, the first sentence. Such exhibits are created and overseen by costume curators. The second thing is, the term costume curators refers to professionals who do this, this, and this. So having two sentences here is not the best because we say costume curators back to back. So we can just springboard right off the first costume curators right into our definition, and that would be a lot smoother. Let's see. So, with A, strictly speaking is not necessary. Little things that you throw into your speech, and when you're talking to someone, you don't need to put them in your writing. It's just strictly speaking, like if you didn't have that in there, the reader would still believe you. It's pretty assumed that what you're saying is true. Otherwise, why would we be reading it? Okay. And then with B, curators. That is to say, costume curators. And then what do they say there? Are. Okay, so that's even more wording. That is to say. We don't need to say that. People don't really say that, okay? C has a semicolon. It shortens it significantly. Semicolon where a period is fine. A semicolon and a period are essentially the same thing. And then the next sentence would be, these are professionals who oversee the acquisition. Yeah, so that's not bad. The thing is there's a simpler way to do it, and that's D. Shorter is better as long as it's clear and still grammatically correct. Such exhibits are created and overseen by costume curators, comma, professionals who oversee the acquisition, maintenance, and blah, blah, blah. That is a very apt way to use this comma. You have a term that the reader hasn't seen before, and then you define it. You have the term itself, a comma, and then the definition. I went to the museum, comma, a building that has lots of artifacts and interesting exhibits. That's how definitions in sentences work typically, is you see the actual word, comma, and then the definition. Keep going. Going to keep going. Oh my gosh. All right, and then chemist, we already did chemist, so we're going back up. Pale moon. I think this will be the last one. Hopefully I'll be able to figure this one out, unlike the last one. Okay. Put that right there, bring that down a little bit. And we're off. Could you both do a group session where you send us drills like a packet with a challenging reading passage, challenging writing mini system math questions, and we go over them with you on Thursday? I mean, technically, this is a group session. Do you mean like a group tutoring session or like a group Twitch session? You want an actual assignment. I mean, have you done all the SATs online? Because, like, the format here is kind of where you take it upon yourself to do sections, and then the ones that you didn't get right, that you're wondering why, you ask us those things. If you want some individualized help, go ahead and text us separately over Discord. You can just DM us, and we can talk about tutoring.
because this is supposed to sort of be for a group session. And like, I'm just about done with all these questions. So like any question you had, it's not like we're running out of time. We're able to do all the questions. Like where we all are prepared with questions. I mean, what I can do is I can we can tell everyone on Discord a specific SAT we're going to go over. So like there's 8 of them. There's actually 10 of them that you can find. And we could just say, hey guys, SAT 8 is what we're going to be talking about on Thursday. So do as much of that as you can and come with as many questions as possible about that test. We can do that. Turtles, what you're asking, the specific creating something for you guys, to be frank, we tutor and we're paid for that. We're not paid for any of this. And this is a lot of time. So like we'll do you kind of have to take some of the goodbye not koozie. You got to take some of the load here on yourself, and we're offering you as much help as you want as long as you come with questions. So like I can absolutely tell you guys a certain SAT that you should do. Not koozie, I will pray for you. Let not koozie do very well. Oh, spirit. Okay, that's true for these investors. That's what I think. No apostrophe with puts, because that's not a contraction or possession. No apostrophe with puts. Last question. In acute triangle ABC, the measure of angle A is equal to 2x plus 20, and the measure of angle B is equal to x plus 46. If sine A is equal to cosine of B, what is the value of x? My fingers are slippery. That's okay. They call you slippery fingers turtles. Acute triangle ABC. Okay, so we have A, we have B, we have C, and none of them are obtuse. I can't sleep at night. Now koozie. Repress, dissociate, repress, dissociate, and then you'll be fine. You just won't feel anything. You'll be empty inside. Knock yourself out with chamomile tie. Chamomile tie. You can do that. Measure of angle A is equal to 2x plus 20. Measure of angle B is equal to x plus 46. If sine of A is equal to cosine of B, what is the value of x? All right, that right there is the kicker. If you do not know this trig identity, then you will not know where to go from here. Sine of x is equal to cosine of 90 minus x, and the other way around, cosine of x is equal to the sine of 90 minus x. All right, this is a whole explanation, but basically if you have some angle x, then the angle opposite that in a right triangle would be complementary to it. These two have to add up to 90. So this angle right here is going to be 90 minus x. If you think about the sine, you got A, B, and C. The sine of x is going to be A over C. And then if you take the cosine of this angle, 90 minus x, it will also be A over C. I'm doing this fast because we don't have a lot of time. So what this tells us, if sine of A is equal to cosine of B, the only way that happens is if those two angles are complementary. So this actually will be a right triangle with angle C being a right angle. A and B have to be complementary, so if you add them up, you have to get 90. So x plus 46 plus 2x plus 20 needs to be equal to 90. They're asking what's the value of x. You add these together, we have 3x plus 66 is equal to 90, which means that 3x is equal to 24, so x is equal to 8. That right there, this is the thing you have to know. I know it's a right triangle, never mind. You don't know until you recognize that this sort of thing only happens when two angles are complementary. And if two angles are complementary, that means they add up to 90, which means the third angle has to be 90, because you still have 90 degrees to go. Everything has to add up to 180. If two of the angles are 90 by themselves, the other one needs to be 90, so it ends up actually being a right triangle. I shouldn't have used ABC here. I was just trying to show where that little trig identity comes from. Yes, not koozie. Yes, we are. I'm gonna cue this thing up, and I'm gonna give you exactly what you guys want. Nerdish.